Alrighty, I had completely recorded this as proper as possible, and it looked so good. It had the perfect quality. It was A tier. And then I went to go save it, and it deleted. So here we are, doing this back again, which is fine, no big deal. But let's talk about the complete and net ionic equations. And so how I kind of like to approach the complete equation is by like breaking it up into their own little compounds. So like you can see the lines here, breaking up sodium, breaking up sulfate, breaking up barium, chlorine. Do the same thing over here. So you can see that they all have their own little things to go off by, and a way that you can see them in the equation better. So let's write it out. Na on this side has a 2, so it's going to be Na2. The charge is +1. The reason why it's 2 is because, for one, there is 2 sodium atoms / molecules in this thing. So there you go. I'm sorry, excuse me. Which is why 2 is going to be dropped down here in the equation. Kind of like adding, but not in a sense adding at all. So next, I like going in order because you can also see kind of how like the equations come together, but it's just me. That's just my preference. Next is SO4. And what you're going to do is you're going to do, which is sulfate, just so you know. Write it out, SO4. There's only one, so you're just going to put it to the negative 2 net charge, plus beryllium, not beryllium, I'm sorry, barium, which is going to have a net charge of +2. Did I say +2 for sulfate? I meant -2. And chlorine, which has a 2 subscript, meaning it's going to be 2Cl with a charge of -1. That's good on that side so far. Let's go to the other one. So, as you can tell, these ones are more of like new compounds. They, in a sense, you could even look at it like they flip around. That's how I was able to kind of understand this good, is I just thought, oh, you know, if these two can bond because of, again, I was just assuming ion charges or ionization energy charges, then that would make sense as to why they bond. So then again, start on this side. There is 2 sodium plus 1 plus there's 2 chlorines, because the 2 in front, think of it like when you were in math class and you had the rainbow equations where it would be a 2 on this side and 2 on here, and you just multiply that in. Same situation. So 2 chlorines -1 charge plus a Ba, which has a charge of +2. And I'm sorry, you don't have to, hold on, let me put these together. So in a sense, you wouldn't write it out like this. I just did that last time too, which is funny because I should have remembered, but it's okay, no big deal. But this is what a completed equation looks like. The complete equation. Complete ionic equation, if that makes any sense. But you're probably asking, so why did you go and erase barium and sulfate? And why didn't you put them as plus? Well, think of the ionization charges, and remember an ionic bond. An ionic bond is where 2 strong opposites, so plus and minus, come together and they form like this. That's even in front of the camera. Yes, they come together and they bond. So think of barium sulfate as, what is it? As a, how do I explain this? As a 1-to-1 ratio. So if you were to take the ionization energy divided by -2, you would get 1. Divide this by +2, you'd get 1. Excuse me. Therefore, it has a 2-to-2 ratio. Kind of the same thing with sodium chloride, except these are not combined. No, they are combined. They are combined. I'm saying no because of how I broke it up, but no, those are combined, which again, these are in aqueous form, and this is a solid form, which I'll explain that later. And yeah, so time for crossing out. And you're probably, I was gonna say, yeah, I'm explaining aqueous and solidifying forms later. But time for algebraic crossing out. Just like what we had done in the last equation, you're going to cross them out like you did in algebra all those years ago, or whenever you took algebra. I don't remember, or I don't know. But see, we have like terms here. crossing out like terms. So you have 2Na on this side, and you have a 2Na on this side. Womp, womp. You have a 2 chlorine on this side and a 2 chlorine. Bump, bump. Now you're left with a barium and a sulfate and a barium sulfate. So let's write it out. Let's write out the rest that we have left. So we have barium plus 2 plus sulfate minus 2 is equivalent to barium sulfate. Okay, so now this shows that the equation is balanced. You have one on this side and one on this side. Only difference is that this one's also broken up while these ones are combined, but again, it's just the same thing, just broken up and put in two different solutions. But I believe that these are also both aqueous because they're liquidated at first and then they become a solid. Because once these two, which I think it's because these are on a metal and an aqueous solution when they combine, or a liquidated solution, they have a tendency to form a precipitate or like a solid. So in this sense, anything that is combined like this typically is a reason or what is formed as a precipitate. So in a sense, as you can see, barium and sulfate form the precipitate of barium sulfate. I know that was probably very choppy, which I'm sorry. I'm trying, okay? I'm a little bit like, ugh, because I'm tired, but it's okay. Again, I'm really hoping this made some sort of sense, and if it doesn't, I can always explain more tomorrow. I should be willing to. And yeah, so let me know if you have any questions.